never have to watch it. Just tell me.
We'll come back to that.
That's all that happened.
Right. Can you check the bars? Mic test, mic test.
Mic test. Test 1, 2. All good? All right. 4. All right. Hey folks, we're going to get started now. If you want to just come to the front and grab a seat, grab a slice or drink on the way here. All right. Can everyone hear me okay? This is just nice, right? Cool. All right. A very warm welcome to everyone to the first data engineering meetup of 2023. We have 2 very exciting talks this evening. But before we get started, a couple of housekeeping matters for us to sort through. Firstly, there is a recycling bin as well and a trash bin, so just be careful on which way you put your trash and where you put your recycling materials. Use the right bin. We have a fire warden as well in the building, so if there's any emergencies, I think it might be Jess, somebody. Yeah, Jess will be ushering us out safely if there is a fire. In terms of bathrooms, so you'll notice there's some key cards hanging on that fire exit button. Don't press the button, but grab the key cards. Yes, and the bathrooms are on the inside. And if you just walk down the hallway and turn left, you'll find the bathrooms. Yeah, that's just a matter of housekeeping. Jumping to the next slide here. We'd like to give a special thank you to our sponsor, Telstra Global, for food, drinks, and the venue. Thanks, Casey, for setting it all up, and Jess as well for helping organize. Did you want to say anything, Casey, or?
Only that Telstra Global is hiring, so if you are interested in that,
Thanks, Casey. All right, jumping off to the next slide here. So I'm conscious everyone has been to the meetups last year, so I'm just going to give a quick overview of what the meetup is. So the purpose of the Perth Data Engineering meetup is to create a community for data engineers to share ideas, patterns, lessons learned, best practices with one another. We also aim to create a place for people to have strong social connections, be able to support one another in your career development. And also our meetup is vendor agnostic, so we welcome anyone working on any stack or technology that you're working with, or any industry as well. So yeah, those are the 3, I guess, values that we hold for the meetup. All right. Without further ado, I'm just going to introduce our first speaker. Our first speaker is Louise. Louise is a senior data engineer from CASA. She's going to be talking to us tonight about blending multimodal big data in GCP. Louise is a seasoned data engineer with excellent analytical and creative problem-solving skills. She has experience with AWS, Microsoft, and GCP data stacks, the 3 big ones, and she's aligned with the Kimball data warehouse design modeling practices. So yeah, without further ado, Louise, the floor is yours.
Hi everybody, how are you this afternoon? I hope you're excited. Some technical things. Anyway, right, so being introduced, welcome everybody. I'm going to be showing you this afternoon how easy it is in GCP to build one single data pipeline to ingest different nodes of data. So let's get started. So what do I mean by multimodal? I can explain this with a bit of a use case. If you have, say I have a company that has to look after cell towers and have to see whether they're up and running. They need that. I have this company that looks after cell towers and they get real-time data fed from the IoT devices from these cell towers all the time. So that is my real-time data, but every now and then some of those cell towers go down and they have to send a technician out. This technician has a mobile application, I think, and he can use that then to send things off to test the network and so forth. You can also grab some historical things that's captured on a device out on site in the form of a file. So what I've mentioned here is basically 3 different ways of data being captured: real-time, intermittent, because we don't know when he's going to click the button on his mobile phone, and he could do a whole bunch of clicks quickly directly after each other and then for a while do nothing. So that's sort of intermittent data. And then of course all of bulk, which is your files. And then there's another one, periodic, which is daily, monthly, that sort of thing, seasonal, maybe only when you get some data. Anyway, I hope that explains it. So the next slide is just a high-level diagram of the solution that I will be demonstrating. So if you see on the left-hand side, I've got my 3 modes of data: bulk, stream, and mobile. All the data gets fed to a pub subtopic. Now, pub sub is my GCP's fully managed asynchronous messaging service. Downstream from that, I've got a Dataflow streaming job. Dataflow is GCP's data processing service. You can do very sophisticated ETL processes or very simple ones. Now, this example is an ETL ingestion. We're going to do some simple transformations in this Dataflow job, segregate the data, and then sync it into 2 separate tables in a BigQuery. So underlying to this is also our cloud IAM security, key management services, and then having the ability to log everything about our jobs and infrastructure in cloud logging. Now, why do we want one single pipeline? Well, the cost for one, we have to maintain only one pipeline. We only have to have one code base. We only have to have one set of transformation rules. So overall, it makes sense to just have one pipeline to deal with all these different kinds of data. But I think I've talked enough on that. So let's move on to actual showing the demo. So I'm first going to show you the infrastructure that I have. This is my pub subtopic, and I have one subscription related to this topic, and that is from the Beam Dataflow job. Now, Dataflow, basically, you can write your Dataflow job using the open source Apache Beam libraries in any of the languages of your choice. And that's what Dataflow does. It executes those transformations you're doing in your code. Now, this one is fairly simple. It pulls the pub-sub message, it parses the message, it extracts some Latin long information, and then segregates those heartbeats into valid and invalid ones and sync it into 2 different tables in BigQuery. That's what this job does. At the moment, you'll see it is currently running with 1 worker. It is currently ingesting data, 10 messages per second, so not a lot of data, so it doesn't need to scale. And I'll show and prove that. So going to BigQuery, I've got my data set here with my 2 tables. So if I select from my valid transponder table, you should see some data. So 9652, and then if we run it again, we should see that increasing. Right, so you can see it is definitely running. Right, so next I'm going to do some intermittent data. So I've got a little bit of a cloud function here, which is sort of emulating a sending a message from a application. So all I need to do is do a test, run here, and it will post a message to pops up. I can also do a invalid one, so it's gonna copy. I have to change my payload to do that. So let's send the invalid one. Right, so we should see that data coming through. So my intermittent ones is marked with a specific ID. So let's see if we're seeing any data. There's some data there. Does that time look right? Yeah, I think so. You can do another one. Let's do the second valid one. Oops. Sorry, Lord. Let's send another invalid one. Right. Go back to BigQuery and see if we've got invalid ones. Should have two. Yep, I sent two. So now you can already see the pipelines dealing with real-time data as well as intermittent data. Beam is not really or Dataflow is not really working very hard, so we want to up the ante a bit. So I'm going to increase the number of messages being sent, and then later on in the demonstration, I'll show you how it's Dataflow scale. So I just want to go. I currently have this Python running, which is just doing a 10 messages per second. So I'm going to up this and open up another terminal. I'm using these open ones. So I'm going to start my simulator with a little bit more data. Yep, that looks a bit faster. So that will start flowing through to BigQuery soon. So if we select from BigQuery again, silence. Right, so we've got 11.619, so let's see if we run it again. That table is being hammered. Right, so you see there's more data there now. Now, next, I want to show you that I can also do some bulk loads. So I've got another Python script here that basically reads a file that's got 10,000 records in it and sends each record as a pops-up message. So I'm just going to start another terminal. Can't quite very well when you know this. Right, so that's publishing data as well. So I'm not going to go to BigQuery. We'll wait a little bit and see when Dataflow is going to scale. Dataflow will be getting a lot more messages now. You can see there's more elements being processed here. What I want to show you as well is that that's fine if I'm doing ETL, right? I'm doing ETL, so I'm doing some sophisticated transformations before I land my data into the database. But what if I don't want to go that route? I rather want to do ELT. I just want to land the data in my data warehouse in BigQuery, and then I'll transform it using dbt or Dataform or whatever you want to use, or old school, just write some SQL, right? So in that case, what's fantastic is that last year GCP brought out the ability to now create a streaming subscription. So I can create a subscription to that topic that directly streams the data into BigQuery. And I'm going to quickly show that to you. So all you need to do is create another subscription. So I'm doing it on that exact topic. I'm just going to do that, write to BigQuery. I already have a data set, and table, which I created before. I'm not going to touch any of the rest of the settings. You can actually split your message into, different fields, depending on your license setup, but I didn't do all that. So you can see there's a whole lot of things like attention and everything. Let's create this. Sorry, I should have played music while this is righto, so that's created. So immediately we should see data coming in. So my select statement here at the bottom is to select from that specific table. And you'll see that data. So we already have a fair bit of data that's flowing in. So let's see if that's increasing. Yep, you can see how quickly that's increasing, right? Okie dokie, so let's see if we've got some bulk data because we switched that bulk one on. So the batch is marked with the ID of bulk. So let's see if our bulk came in. Yep, we've got a few bulks there. I reckon it might be a good time to see if this thing is auto-scaled. It's not showing yet. I'm a bit too fast for it. And I was going to show you, like I did do this work today before we started. So let's see, I might have a message coming through on here. Yeah, it's not saying that it started scaling yet. It usually takes a few minutes to scale, but I mean, that sort of concludes my demonstration. I'm happy to leave it on there for a minute or two and see if it actually refreshes and show us that it's scaled. Yeah, no, it's lazy. Yep, so I'll just go back to my talk slides for now. So what I've shown you is that you can actually do ETL or ELT dependent on your choice, that you can stream all different types of modes of data using one pipeline through a subtopic. So I guess next is questions. Does anybody have questions for me? Yes.
You've mentioned Dataflow and you've mentioned Beam. What's the difference between?
Oh, sorry. So Beam, my mistake. So Dataflow is the implementation of the Beam, Apache Beam library. So Dataflow is just the engine that runs it for you. Beam is actually the library. Sorry, I know my mistake. So the yeah, all good. Let's see if we can see that scaling happening. Yep, there you go. Current workers 11. So you see it scaled up. Right. All good. Anybody else? Yes.
You've used data engineering products across different cloud platforms. What do you think the developer experience for something like Beam and Dataflow, or how do you think it compares to what you have to do on AWS or Azure in terms of either the setup or the programming model to deliver some value?
I think Beam libraries is fairly complicated. I think if you're a Java developer, it's easier for you to do because it's basically written in Java. I think the rest of the libraries are all sort of put on top of the Java. And I'm not a Java developer, so I found it quite hard in the beginning to learn. So I switched to Python because lazy maybe, but it supposedly doesn't perform as well. I don't know. I haven't proven that to myself. It's just hearsay, I would say. On AWS, we use some glue, but it's got its own issues. So it's very difficult to really compare the two. I think you can do excellent transformation pipelines. That's very complicated, but maintaining it and having enough people with the skills to maintain it can be an issue, I would say. I mean, you'd find more people. Well, if you have Java devs, right, throw them in there, they do excellent with B. If you have SQL people that, like me, that's from SQL background, you'll find them maybe more suited to do things in a database.
But you transitioned well,
Oh,
so it's possible. It's
alrighty. Anybody else? Can I run, please?
Thanks, Louise. All right, where is our next speaker? Where is Thomas? Hi, sir. All right, so our next speaker is Thomas. Thomas is a senior data engineer at Woodside, and he'll be talking to us about unit testing for GPT incremental models. A bit about Thomas. Thomas is a senior data engineer at Woodside with 10 plus years experience across data engineering, data analysis, and operational reporting. His experience in software engineering has given him an interest in the application of software engineering techniques to data warehousing problems. Okay, without further ado, Thomas, the floor is yours.
Thanks, John.
Yeah. Oh, okay, I think it's gone the other way. I think so. It's the around. Yeah, sorry. Cool. Good. Yeah. I just need to set this one. Yep. And then present screen.
This is from my phone.
Share screen. Share screen again. And then just go to the entire screen like that. Like that. Cool. Good to go. Yeah, just quit and reopen. Sorry guys, give us a minute.
Yeah.
Yeah.
It's the GCP service. Yeah.
Screenception.
Right. Today I'm going to talk to you about unit testing in incremental models in DBT. First of all, for those who might not be across DBT, probably not many people in this crowd, but I thought I'd better cover this anyway. Essentially, DBT is a tool for managing transformation within a data platform. So there's a Ginger templating engine that's typically used with SQL for building some macros, allowing you to avoid repeating yourself and to have models that can deal with the schema of tables that you're dealing with in how you're populating your transformation. There's some dependency graph sort of management, so you can have a sequence of different transformations that depend on each other and use DBT to an extent to manage execution of those in a sequence and relating them to other objects that you've got in DBT. And then the other key function is data testing. So looking at making sure that the data that's coming through meets your expectations, essentially. I guess a bit of context around what DBT is used for. It's really popular in an extract, load, transform rather than an extract, transform, load context. So starting off with your source data, it generally doesn't really deal with the ingestion component so much. A lot of people are using different frameworks for streaming straight into your platform of choice of Snowflakes or Databricks or BigQuery or things like that, or using sort of your general out-of-the-box ingestion tools, things like AirBright and that kind of thing to land data. Once that's in, you typically would see in an ELT architecture some raw layer of the data. And I guess the concept here is that you're landing data that's very much like source, not a whole lot done to it, and then transforming it within your data platform. Often you'd see some sort of cleansing or modeling of data, various architectures for that, and varying numbers of layers, but I've just compressed it here in the middle because it's more about concept, and then some kind of serving layer. So where DBT sits in that, often it would be triggered by some kind of orchestration tool, could be DBT Cloud, it could be if you're using just the DBT core product, you might be running that from a separate orchestration tool. And DBT really has the function of executing some models, which are your SQL scripts that define the transformation that's going to happen to data, and then managing the sequence between those as the data flows from what you've got in a raw layer to your reporting and analytics or other consumption of that data. So really, DBT is about defining and executing that transformation. The actual compute and processing grunt work is happening within your analytical data platform. So it could be SQL statements running on compute in Snowflake, or it could be some Databricks jobs that are being spun up and that sort of thing. I guess a lot of the appeal of the ELT architecture is about trying to strip back what we're doing in processing data to pure functions, where when you have a particular input that's coming in, you're always going to have the same output. And there's not this messy dependence on state of what we've read before, or looking at the state of the previous table especially. That gives us some benefits in terms of being able to easily scale out what we're doing in parallel. If we don't need to worry about what's happened before, then we can distribute across a cluster and have each one worry about a partition without needing to know what's going on the others. It gives us more reproducibility of results. So we know that we don't need to worry about what data we've already processed sitting in our database. It's only really a consideration what's coming in and what's going out, which is great if we're trying to deploy in dev and test environments versus prod environments, because we have that confidence that if we're running the same model, we're going to get the same outputs without needing to think about the state that we're starting from. And it also helps with testability. If we've got a clear picture of where we're going and don't have to worry about so much of the setup to get initial state and test permutations of state we're doing. Incremental pipelines, on the other hand, typically have some dependence on the prior state of what you're doing. So you have some new records coming in, some target that has previous results from where you run it before, sitting in your target database, and then the combination of those two things kind of married together to give us our final results. This introduces problems with locking and contention because you're looking at what you had before. It gives it more difficulty to reproduce what you're getting at because you now have to worry about what state to start off with in your database, and it makes it quite a bit harder to test. So why go incremental? The bottom line is that it comes down to cost. Costs can tend to grow quite quickly as the size of your data set does. It depends a bit, I suppose, on what data you're working with, what platform you're working with, and that sort of thing. But ultimately, you end up reaching a point where the costs of processing things incrementally may be significantly beneficial, especially if you're looking at materializing results and truncating and reloading rather than just using views across results. Then just processing what you need can have a significant advantage there. Views can be another way to manage that. So deferring the compute cost to when someone's actually using the data, and hopefully your database platform might be smart enough to do some optimization to apply filters down from your top level to notice that you're only looking at a narrow range of dates. So maybe it only needs to read a few micro partitions in storage rather than scanning the whole table. But that again still depends very much on the structure of how your data is laid out on disk. If you're using windowing functions and stuff like that, it's going to cover a wide range of partitions. Then the efficiency benefit you can get by reducing what's scanned can be impacted, and you may find that you end up with higher costs depending on how much is used and how well the results can be cached. So not always up for cost. The other thing is that where those levels of where incremental is useful can vary a lot depending on the platform you're dealing with. Not all cloud database platforms or architectures are equal in terms of how efficient it is to do merges, if it's even possible to, versus appending new rows or deleting partitions and recreating them. So that can be a big factor in deciding what's going to be most cost effective in terms of incremental processing. So jumping to how DBT does it. DBT has a built-in materialization for incremental. This is alongside the ones that you more commonly see in terms of materializing as a table view. You can see on the right there, we've got a little config ginger block, which is specifying that this model is going to be built as materialized. And we also got a key in there, which is telling DBT that we wanted to look to delete rows that have this ID or update them. Essentially, the effect we're getting with an incremental model is an upsert against the table. But the actual implementation and how it's executed depends on the database that we're targeting. In some cases, it could be a merge, and in other cases, you might see it doing a delete of previous rows and then inserting new ones. There are some other strategies that are used there as well. So the first time we run one of these models, your incremental section you can see there in the if statement in Ginger, where you've got the source table, that will return false. So that allows us to essentially put in some of our own code when we're defining the model that goes how it runs. Most often, you'll see at least to start with some kind of condition that's restricting what you're pulling from the source, as we do here. But I guess the rest of the differences between how you want the model to run the incremental versus how you want it to run when you're doing your initial full run can be very dependent on what you're trying to do. The first run being on incremental really depends on the existence of the target in the database. So there's a bit of a gotcha if you've got a empty target that you're trying to write to. And that's why you see this coalesce statement here against the IDs, trying to provide a starting point, because you really want it, if you're running an incremental run against an empty table, to make sure that you're reading everything as though it was a full run. I suppose there's other ways you can manage that if you need to, though. And then if you have a need to rebuild the complete data set, DBT provides a full refresh switch that you can apply when you're running that model to rebuild the whole thing rather than using the incremental logic. Jumping across to testing. So there's a few different high-level classes of kinds of tests that we see often in the data space. One is about unit testing. which is usually using a very small test data set. You generally be looking at how you can validate boundary cases with this. So it's generally very fast to run because it's a small data set. You might be looking at scenarios that don't occur very often in real data, but are kind of some of those edge cases that you want to handle, as well as validating your sort of basic expected behaviors. And often these can be implemented by taking a test data set that's quite small and checking that the actual results you get and running the model against that match expectation. The other kind of tests that you often see in the data space are what I like to call validation tests. And really that's where you're getting some real data and you're applying some checks against it. It could be your source data that you're looking at to assess whether it matches some of the assumptions you've made in terms of having uniqueness or referential integrity or being as fresh as you expect it to be. Or it could also be assertions that you know need to apply to the result you're producing. I guess referential integrity is a simple and good example there because you don't want the users of the data to find that rows are unexpectedly dropping because of a join that's missing from one of the tables or something like that. Typically those can be a bit slower to run, so they tend to be ones that you don't necessarily want to run as part of your development cycle all the time as you do the unit test to check that your logic's working as expected. So looking at what DBT has, we have a couple of classes of tests that come out of the box. One is a singular test. Essentially, you're writing a SQL statement that you want to run, and the default behavior with singular tests will be if there's any data that comes back, then the test fails. So you're looking at providing something that, in this case, checks whether there are any duplicates. We're returning the duplicates across that set of columns as the result, and then DBT will give us a failure if there are any. These are good where you've got something that's a fairly non-standard and specific scenario you're looking at. But if you're writing tests against lots of different models that are looking at the same thing, that's where a generic test becomes more useful. So there's quite a few standard ones that are available from the DBT utils package, and DBT expectations is another great source of many tests for this. The difference here is we're getting some reuse. So this is essentially a macro. Could be one that you've written, could be one that comes as part of a package. It's this one from DBT utils does. And we're configuring that predefined test macro for the particular model we're looking at. In this case, giving a list of columns that we expect to be unique. So it's really the same thing as the other one we have on the left. But we've had to do less work to write the code and reuse it. There's a few limitations with this. The incremental materialization logic doesn't kick in when you're running singular tests. So I guess one strategy, and when I come to look at a bit of demo with some code later, I'll show you an example of this. One strategy with unit testing is to write a macro that's essentially running some of your code modularized into a macro, and then doing a comparison of expected against actual to see if there's any rows that are different or the row count's different. But obviously, if you're trying to test an incremental model and DBT's incremental logic of how it applies to a table kicks in, then you're testing something quite different from what you actually want to run, which is very helpful. There's not a mix of options for running full incrementals if you're trying to put it into a singular test either, which is something you need. And you don't have options for running the same test multiple times. So in an incremental scenario, you may want to do an initial load for your tests and then do a few delta loads after that to apply a few results and check that the result of those few things together is what you expect. So that's not really possible then. But if they're all essential things for testing incremental models. So the question you have to ask yourself there is, how's it done in DBT? They must have some tests within the application to do with this stuff. There's adapter testing framework within the DBT core plugin. So the adapters are where DBT houses the database-specific elements of the code, and that has things like the different implementations of the incremental strategies that we're talking about, which cause it to merge for some databases and insert pen for others and other options like that. And the adapter modules there's some testing sort of framework code that's in the DBT libraries to deal with those, which is suitable for us in trying to unit test our own incremental models. PyTest is what DBT uses for those scenarios. And essentially the way that the PyTest code they've got works, it builds and runs a temporary DBT project in a folder, gives you some options for configuring per test or per test suite, what different configurations you want to have, so generating all of your project YAML files and schemas and that sort of stuff that would control how it works. And it also gives you some help functions that help with your comparing expected versus actual and other kinds of assertions, whether it generates errors and all that sort of thing. Okay, so let me just fire up. For what I wanted to demonstrate here, I've come up with a very simple contrived example. So we've got a small data set here that was related to something I was looking at work, where you've got some alarms on some group tags at different times, but we're seeing most of the values up to a time column staying the same, but after the alarm's generated, there's a change of status that's coming through in the same table, and we've got some receive times associated with those different statuses. We've also got some duplicates here if you look at rows 4 and 5. So in my highly contrived example, the objective we're looking for is to see what the last time that we saw one of these statuses arrive, and taking out duplicates for our result. Okay. Jump across to VS Code. So here's a full model that's not using incremental, based around that approach. And we're using a keep first in a macro in this case to grab all the columns, partitioning by everything but that receive time, but we want to order the rows that we're deduplicating on by. And then an ordering expression down here that's going to define it. So this is another example here of how you might test that. So I've kept this logic for the keep first as an example in a macro that we could unit test. And when we come over to here, the sort of flow of this approach looks at taking an input set of rows and a expected result. I'm defining these as SQL statements because it's convenient to being able to run it all in one query without having to think about creating seeds or converting CSV data or anything like that. Then we've got a block of SQL that we're defining here based on the function to use, a macro rather, to use this block of code that we've defined up here and to compare it to our expected result. So macro defined here to deal with that. All I'm doing in this equals expected is essentially a set difference to detect rows that are different between the two, and also a comparison of row counts just to pick up cases where we might have different numbers of rows in those. So if we look to run that simply, actually, yeah, let's go with that. Of course, if I can type, we'll get more effect. Okay, and that's telling us that our macro is no good because we've got duplicates. And looking back here, that's because I've introduced a convenient rookie mistake to use a rank instead of a row number. So we dealt with the scenario where we had different times, but in that case where we saw where there were two exact duplicate rows, it's not giving us the desired result. So we could just flip that over to get a more useful result, although I'll keep that convenient rookie mistake in here for now for the demonstration of our incremental test. Okay, if we come back to looking at how we could turn that into an incremental model, so we've got our incremental config and a few sets of columns that I'm defining in Ginger lists here for convenience. here's sort of what we saw before of his incremental logic and our logic to filter what's coming in the source tables. We've got our keep first logic similar to what we had before as well across those new rows that are coming in. And then when we've got incremental runs, we've got some more complex logic to do a join against the target, in this case, to pick up which rows aren't there already, and which ones we want to update. So this becomes important for the receive time condition, because if we had a duplicate that had existed in the source table that was also in the target and it was an incremental run, we might have a situation where we're inserting another duplicate because it's, the duplication function doesn't apply across both of them. Okay, coming across to the incremental testing. So there's a little bit of setup we have to do with PyTest to get this going, bringing through the fixtures for the DBT test project is one part of it. Also here you need to set up a profile of what database you want to run against. In this case, I guess that's more designed for the unit testing of the DBT scenario, where you're looking to test your macros, something like what I've done here, that is just taking the profile file that you're using when you run DBT. It's a simple way to get it working. Then if we come across to what we've got in our Python unit testing script, so we've got some imports of some of the functions from here, and I've got some code here for testing against expectations. We've got some fixtures coming through from the PyTest stuff that's set up in the DBT core project. So this project fixture here that's coming through is the key one that sort of wraps most of the things that you need, unless you're going to look at defining your own fixtures. This is essentially running, in this case, some SQL statements. So we want to make sure that the tables that we're using for our test don't exist, and then creating our table for our expected result, dropping the table with the initial data, and then running DBT to build our model with a full fresh switch. I've written this to run for a list of different sets of rows as deltas, so you can execute it in different sequences there, and then we go over a loop over each of those to run an insert and then a run of the model to build our incremental result. Then our final step here is to run a check that the expected result in the database that we created matches the results of running our model multiple times. Looking at the test class here, we've got some fixtures around reading packages. There's another gotcha to be aware of if you're going to use DBT packages with this, which I think is just because the usage for testing DBT core doesn't really apply. But there's an assumption that it makes that the first time you run DBT, that there will be a valid adapter left over for it to use in executing code against the database. If you run DBT deps to install packages as your first step, that doesn't get created by nature of what it's doing. So you need to make sure that there's a debug run after that, so that when we come back up here and try to do our run SQL, we don't get errors telling us that there's no such thing as an adapter for whatever database we're running against. The other fixtures we're looking at are more the ones you'd expect here. So we've got one that's defining the macro file we're looking at. Here I'm reading it from the macro that we've written because that's what we want, but you could be including some macros just in here. So essentially these are each defining a dictionary that maps some kind of file name to the actual code we want. And the DBT testing framework, when it's creating these files, will give them the extension you specify here. So the .SQL or YAML will control how it's going to be interpreted. Similar story with the models, so you can see we've got a mix here of the YAML file defining our source and then our incremental model that we looked at earlier. So coming down to some of the tests that sit in here. So I'm defining a set of input rows, and again, I'm doing this in SQL just because it was easier and quicker for me to do it that way than defining some CSV file or something else to upload. A bit of trickery in here that I won't get into unless anyone's particularly interested, but essentially what it's doing is taking our sequence of rows and partitioning it in different ways. So if we have, in this case, we've got 2 copies of this one row as exact duplicates. And what it's going to do is it's going to split that and say, I can put them in both together in the initial, and that needs to work. I can split them up, so the first of the duplicates is in the initial, and the second one is in the delta, and that works. And if we had 3 or 4 rows, then this function would be coming up with all the permutations of ways that you could run those still in sequence, but in different groups, scenarios where that makes a difference. Then we're looking through those permutations and running our function to compare expected results against actual. So just unioning all in here because we had SQL statements at the top. And I've done a similar sort of test here for our scenario where we have what's kickstart the first receive time. So we're generating a few rows here with different receive times, but everything else the same. And then very much the same logic here, comparing against incremental. So we can run these from the console just with PyTest, and once it's all set up, or we can also kick them off from VS Code in here. Hopefully it doesn't take us too long to run. If it does, I'll blame my laptop being plugged into power. There we go. Okay, so as we expected, because of my convenient looking mistake in our kick first model of using the row number, when we're looking at our test, we're seeing that this scenario of eliminating exact duplicates is not working as we expect. So if I go back through here and take out the rank and bring in the row number, and again, after a suitably lengthy pregnant pause of waiting for tests to run. Okay, there we go. It's happy with that. So our tests are doing what we expect. And we've got our outputs in here for looking at the details of exactly what comes. PyTest is excessively verbose by default in how much it volumes as the tests are running. So it's definitely worth, if you've got some that are failing or if you're using this to try and put in some filters around just how much it logs. So you're seeing stuff that's more meaningful, or I guess redirecting into a file where you can usually easily search what you're looking at. And that's about the lot that I had to present. So any questions for anybody who'd like to know more about any part of what I talked about?
I have a question for you. So how long would you say it would take, or how much longer would you say it would take to develop an incremental model, including like development time model, build and test, as opposed to just a regular full refresh model? I know it changes depending on like the source, but just a gut feel for like the whole process.
I would sort of expect that you'd end up with, if you're looking at similar complexity for 2, I'd say maybe 2 or 3 times as long as a starting point, but so much depends on just how complex your model is. And some models, if you're just appending rows after a timestamp in your incremental model, might be extremely simple, especially if it's source in an event stream. And if you're building like a history tables type 2 type thing in an incremental model and trying to deal with last modified dates from the source database in the process of incrementally loaded data, that gets a whole lot more complex.
Is there any rule of thumb, or from an industry perspective, on economies of scale to use either or? Are there any bits or truths about?
Not that I've found. I'd say really cost would be a big driver when you start thinking about whether an incremental model is worthwhile. But really, I think you need to test it and see, because there's so many. It depends on the complexity of the model and what you're actually doing. It depends on the data set you're pulling in, volumes and row widths, and on the platform you're running it on. So yeah, I think it really comes down to trying to identify pain points, and then you compare what you've got either way to work out whether it makes sense or not.
So how do you sell that to a CEO? Because they always go, well, what's that kind of, what's that benefit? And as you say, it takes that testing all that sunk costs to understand the value of it, isn't it? What's your experience?
I'd say that I wouldn't see this as being something that would necessarily be driven by being sold to a CEO. I think really I would see, as a general rule of thumb, start simple with a complete model. If it's clear that you've got a pain point and cost that you need to solve, that's where you might want to start exploring this. That's kind of what I would
Cost
suggest.
of driver as well.
And I suppose compute time is the other thing. Being so closely tied together, the processing less rows usually takes less time, but not always. So,
I guess my first question is, how much of this incremental testing suite have you had to build from scratch in PyTest versus leveraging plugins and that sort of stuff?
So what I've done here has been focused on leveraging what already exists in the DBT suite. So essentially this, the code I've shown here, plus the few functions that I referred to that I didn't show, that's what I've written for this, and it's really more, there's a little bit around the fixtures of setting up models and that kind of stuff, and a little bit around that logic of creating the tables and comparing the results. But a lot of the code around creating the temporary DBT projects and executing that and all of those things, that's handled by what's already written in DBT core. There are some other libraries that do similar things for unit testing in DBT that are around the place. A lot of them are more focused on kind of more that unit test scenario that we looked at first. We don't have the incremental model and trying to make testing a bit more BDD sort of style. But there are some that do with incremental testing as well. I guess the advantage I saw in exploring this approach as opposed to those is that you're only depending on DBT core libraries rather than needing to bring in sort of code that someone's published and you're not sure how maintained it is and all that kind of thing.
And let's say I already had an incremental DBT pipeline and I wanted to experiment with this sort of framework. Do you have something public that's like a template for this sort of thing or anything like that?
I haven't at this stage. I'd certainly be open to publishing some of what I've done here onto GitHub if there's interest in taking a look.
So where are the tables created actually? So it doesn't use any external processing engine. It's runs locally. So
in my specific example here, I'm running a local Postgres instance.
Right.
So that's where all of the computation of those models is being pushed.
It's similar to that. How have you found the testing suite of, say, DBT core versus cloud? Like, is there any difference between implementations and potential scaling?
This sort of stuff, when you're looking at using PyTest to test incremental models, I don't think you get from DBT Cloud. It's very much focused on running those out-of-the-box, more validation-oriented tests that DBT is good at. I've worked more with DBT core being deployed from GitHub rather than with cloud DBT. So not so much experience to speak from on how much value you get out of DBT Cloud for the test suites in that space.
Is there a generated report on the DBT side of it, like for test?
So there is functionality within DBT to log test executions to a database, which you can then put through into your own models and reports if you're looking at that sort of thing. Although in this case we're using PyTest, that's not going to go into the standard DBT frameworks unless you wanted to do some extra work to put it through. PyTest does have functionality for producing like your sort of JUnit style XML test reports that you can then integrate with a bunch of different tools if that's what you're looking for. So to surface results from GitHub or Azure DevOps, whatever you're using.
What is the advantage of this approach versus black box testing? So you treat results of the runs of DBT as few tables and Postgres that you have, and just use some external testing.
So really the goal here is to have a automated regression test suite. So I suppose the idea is that you could look at putting some of these unit tests, which I haven't done here, but putting them into your CI pipelines. So if someone's making a change to a particular macro, you can kick off your suite of regression tests so you have that confidence that it's not breaking things. And that way, I guess you've got a better development cycle and less defects being introduced in prod. Certainly, you could do similar testing by setting up your initial state, run the macro, check what outputs you've got. So really, this is focused on trying to automate that from a regression scenario, particularly that benefit of being able to rerun things consistently and if there's any defects introduced, making changes.
Cool. All right. Well, thanks, Thomas. All right, that concludes the talk for tonight. Just got some final messages before we jump back into chatting, and there's still some pizzas and drinks if people want to get some. But yeah, we're looking for speakers, so if you'd like to put your hand up to give a talk, if you feel inspired by what you just heard, hop over to that link there, dataengconf.com.au/form/meetup talk, and submit a talk idea. Ash and I, we're around as well on social media, on LinkedIn, to support you if you have any questions or you want to float some ideas across with us. We're happy to collaborate with you on coming up with a talk. A bunch of ideas here as well if you want to do a talk on something. Data orchestration is one that I love, as Ash would know. Analytics engineering, which like Thomas has demonstrated with DBT incremental testing. Lots of topic ideas here. Feel free to chat to us if you want to, find out more and come up with ideas. If you have any suggestions or feedback as well regarding the format of tonight, perhaps you want to start later. I know 5 o'clock might be early for some. So if there's anything you want to provide us feedback for as well, feel free to reach out to either myself or Ash, or any topics you'd like to hear more of. We can try to hunt for speakers on these topics as well. Chat to us about it. More than happy to explore. All right, that's it, folks. Thanks again for coming down tonight. Feel free to stay around for a bit longer. How long is this space open to? 7:30? All right, feel free to linger around till about 7:30. Then we'll kick you out right after that. All right, thanks, folks.
I just get like the number of people.
Yeah.